Another transformation in DSC will be the reflection. Now, we only concerned about two kinds of reflection. One is reflection in x-axis, that is an up-down reflection. If the original graph is like this one, for example, like this one, and then you do an up-down reflection, that is the reflection in x-axis, it becomes something like this. Alright. Now, the interesting thing is when you do an up-down reflection, all the x-axis points, they are constant. These points, they do not change in an up-down reflection. If the original graph is y is f of x, then we just apply a negative sign for the up-down reflection, and the negative sign up-down will be applied outside the bracket. Alright, like I said, this is going a recurring theme. Up and down will be outside the bracket, left and right will be inside the bracket. So that is reflection in x-axis. Reflect in x-axis is an up-down flip. Alright. Now on the other hand, if you do a reflection in y-axis, if the graph is like this, alright, or if the graph is like this, alright, you do a left-right flip, then the graph will become something like this. Alright. Note when you do a left-right flip, then the y-intercepts, they do not change. If you do an up-down flip, then the x-axis do not change. If you do a left-right flip, then the y-intercepts do not change. This is reflection in y-axis. Alright, so if the original graph is y being f of x, then the new graph is y being f of minus x. Alright, reflection is just a negative sign. Alright, but if you apply the negative sign outside the bracket, it is an up-down flip. Reflect in x-axis. If you apply the negative sign inside the bracket, it is a left-right flip. Left-right flip, reflection in y-axis. Alright, so that is the major difference between the two. Alright, whether it is up and down or left-right is just a negative sign. But see if you apply the negative sign inside or outside the bracket. So say for example, we have this graph. It says y is x squared and 4x and 3, right? This red one. We do a reflection in y-axis. Now, if this is f of x, right? A reflection in y-axis, what does that mean? That means f of minus x. Alright, we just copy from the idea here. If we do a reflection in y-axis, that is f of minus x. So what is f of minus x? F of minus x means you replace all the x's with negative x. You replace all the x's with negative x. So minus x squared is still x squared. Alright? So that is x squared. 4 times minus x becomes minus 4x and 3. So this is the new equation. Alright? Now, but similarly, let's do something similar. Let's translate this 4 units to the right. Alright, translate 4 units to the right. Now, if you translate the graph 4 units to the right, what does that mean? That means y will be f of x minus 4. Alright, 4 units to the right if you recall translation. So f of x minus 4 means you replace all the x's with x minus 4. Alright, this becomes x minus 4. If you translate 4 units to the right hand side. Alright, so that's x minus 4 squared and 4 times x minus 4. Alright, so let me expand this one. The first one is 1 minus 8 and 16. Alright, this is the first term. The second term will be 4 and minus 16. This is the second term. Alright, and the third term is a 3. So add all of them together. The purple equation will be x squared minus 4x plus 3. Alright, so that is the purple answer. But interestingly enough, the purple answer is the same as the blue answer. Alright, but they are not the same transformation. One of them is reflection in y-axis, is a left-right flip. One of them is moving to the right-hand side by 4 units. So how come they become the same equation? Why are they the same? They shouldn't be the same, should they? Because they are different transformations. Now the answer lies in the special feature of the red graph. Alright, if you look carefully about the red graph, it is a parabola like this, right? Cutting the 2 points at -1 and -3 respectively. So that is the that is the red one. Alright, the red one is a graph like this. Now if you do a left-right flip, alright, then it becomes the blue one, left and right. Alright, do you get this? Left-right flip, it becomes the blue one. So that -1 and -3, the two roots, becomes 1 and 3. When you do a left-right flip, the y-intercepts do not change. Alright, so what was -1 becomes 1. What was -3 becomes 3. Alright, left-right flip. However, if you take the same red graph and try to move the red graph to the right-hand side by 4 units, alright, you will get this one. Alright, if you move to the right-hand side by 4 units, -1 becomes 3. Alright, -3 becomes 1. So it turns out that they are the same graph, the blue one and the purple one, even though they were achieved by different transformations. But from the equation, you see they are the same graph nonetheless. So it may happen that different transformations will arrive at the same equation. Well, then let's look at one past paper example. Alright. So like last time, we have the red graph, y is f of x. So this is the red graph, right? So these are the red graph. And also this one. And also this one. And then the new equation is y is 1 minus fx. So which one corresponds to 1 minus fx? Which one is most likely 1 minus fx? Now 1 minus fx actually is a distractor. Alright, the better way to state it would be y is minus fx plus 1. Alright, so you will know the transformation involved. Say you start with y is f of x. Alright, let me put that in red. Y is fx. Alright. Now, what does this negative sign means? This negative sign means a up, down, or left, right. If it is applied outside the bracket, it is up, down. Alright. So you do an up, down flip. You do an up, down flip. Alright. Then you arrive at the green one. The green one will be y is minus. Oh, should I use another color? Let me arrive at the yellow one. Right. The yellow one is f of minus f of x. Alright, it's the signature of an up-down flip. And then what do you do? You take this one and then you add 1 to it. Alright, you take this yellow one and you move it upwards by 1 unit. You add 1 to it. You move it upwards by 1 unit, so it becomes the blue graph. Y is minus fx plus 1. Alright, that plus 1 is moving upwards by 1 unit. Alright, so that is the entire story. You take the red curve, you do an up-down flip, and you move it upwards by 1 unit. So among A, B, C, D, which is most likely? Among A, B, C, D. Suppose we cover the green diagram, right? The yellow, we cover the yellow diagram. The red one, you do an up-down flip, this becomes the red one, you do an up-down flip, this becomes the yellow one. Right, the yellow one will be like this. Right, remember the up-down flip, the x-axis, they do not change. Alright, so the yellow one will be y is minus f of x, and then you move the yellow one upwards by 1 unit so that you have the blue one. Right, so the answer to this one is most likely A. Right, the answer to this one should be A. You do an up-down flip and then you move up by 1 unit. Okay. So what are the answer? What are the other answer? Right. For example, B. Right. B will be you do an up-down flip and then you move to the left-hand side by 1 unit. You move to the left-hand side by 1 unit. Right. So this one will be you take the yellow one and then you replace all the x's with x plus 1. So this is most likely the answer in B, the negative of f of x plus 1. You do an up-down flip, becomes the yellow, alright, and then you move to the left-hand side by 1 unit. So similarly, for the part D, for the answer D, that would be minus of fx minus 1. You do an up-down flip, and then you move to the right-hand side by 1 unit. This minus 1 is moving to the right-hand side by 1 unit, for example, alright. And how about C? C will be from red to yellow with an up-down flip, and then you move it downwards by 1 unit. So for answer C, it is probably minus of fx and then minus 1. Alright, you move it further down by 1 unit. So this one is probably y is minus fx minus 1, right? So this is the answer in C. Alright, so they are very similar in terms of the equation, but the graph, they look very different. So based on this idea, we can look at yet another past paper question. So we got the graph, y is 16 minus bracket x minus 6 squared. So there are two ways you can do it, right? The first is an algebra method. You literally expand the bracket, so that is x squared minus 12x plus 36, alright? And then you recover a quadratic equation from here. And then what else? Minus 20. From here, you analyze the feature of this minus x squared plus 12x minus 20 and see what are the feature that meets A, B, C, D, one of them. Alright. Alternatively, you can do it with a transformation approach. Alright. Now imagine the story. There is a prototype. The prototype of this equation is y being x squared. Alright, so we do a lot of transformation based on this one. For example, first of all, we try to move it to the left hand side by 6 units. So it becomes y is x plus 6 squared. Oh, minus 6, sorry. Minus is to the right hand side. Sorry, I move it to the right hand side by 6 units. So that is the purple one, alright? Y is x minus 6 all square. And then I do an up-down flip. So it becomes y is negative x minus 6 square. Alright, this negative is from the up-down flip, right? This minus 6 is from the movement. What else? And then I move it upwards by 16 units. Alright, and then I move it upwards by 16 units. So the new y will be, I'm running out of space. So let me squeeze this a little bit, sorry. Alright, and then the new y will be, y is 16 plus that previous number, that previous function. So that is minus x minus 6 squared. Alright, so now you have this story. You can take the original red graph. It is y being x squared, alright? So you move to the right hand side by 6 units. This is the purple one. Alright, move to the right hand side by 6 units. And then what else do? You do an up-down flip. So that is the yellow one. Alright, you do an up-down flip. So that you have the yellow one. With the yellow one, you move it upwards by 16 units, right? Well, 16, I don't know how much is 16, but let's say this is 16, right? You move upwards by 16 units. So that's the equation. The green equation is something like this, all right? This is y being 16 minus x minus 6 squared. So that is the entire story. Now, with this one, you can take a look at A, B, C, D, which is the better answer. Does it cut the x-axis? Yes, it does. Alright. Is the graph opens upwards? No, it isn't. Alright. Is the intercept 16? Y-intercept 16? I don't know. Probably not. Alright, because from here you know that the y-intercept shall be minus 12. Alright. And does it pass the origin? No, it does not pass the origin, obviously. Alright. So the answer is indeed A. So that is an algebra approach. You can do it by looking at this quadratic equation, or that is a transformation approach. You try to decipher this green equation as a story that takes from the original red one to the purple one to the yellow one to the green one, so that you can roughly sketch the idea of the green one. Right? So that is about reflection.